Hello, and this is the first session in Sheet Gates. It is the hands-on session one. So I'm going to cover a very high level, and the expectation is that you have a basic knowledge of container management, of various runtime engines like Docker and Swarm, and some idea about Kubernetes. And I am going to reference the book Kubernetes Smooth Sail that I published recently. This is basically, it covers a lot of examples and hands-on lab work for everybody, for anyone who wants to get their hands on and then get some experience working in Kubernetes container management space. So the beginning, when you want to go hands on, definitely you need a lab, right? So, but there are different ways. There are apps out there like the Play with Kates and Katacoda that you can just directly log in, and then they have a basic cluster for you, and then you can start running your commands. But there's also a way in which you can set up your own cluster, which is a little bit complicated, but you can still, of course, do it. There are a lot of information on the web about it, and there are some documentation links that I provided. So in my lab, what I did is I have my own cluster. I use kubeadm commands to set up a minimal cluster with one manager and two worker nodes. So what I did is in AWS, I have three EC2 instances, and each one of them is a basic free tier. I use the AMI with the and I install. I'm going to just show you my cluster in a bit, and but I wanted to just first go ahead with the basic of kubectl control plane. So the control plane contains of manager plane and the workers. So manager is basically, in this I'm showing three managers and like six. This is like a production kind of a scenario, because you don't want to just have one manager when you're running production workloads, because with one manager there are chances the manager goes down and you lose the manager, that VM or that node for some reason, then your cluster is in unhealthy state. So three managers is it uses the raft algorithm, and three managers, one of them becomes a leader, and they're always there. It provides high availability for the cluster. That's the whole idea about running your workload in a orchestrated kube cluster. So in this, I have shown three managers and six worker nodes. And what you see, the cubes are basically pods. Pods run on the worker nodes, basically the workload. There are other pods that run on the manager, but they are related to the system level stuff, that cluster level management. But the workloads or services, we can call microservices, they run inside the container, and the container runs inside the pod. And it's up to you, the team, how you want to do it, but it's usually a one-to-one and container to pod deployment, but it can definitely be more than one container in a pod. So let me show you my cluster. So if you see here, right, so okay, so I have three nodes. So if I do, it'll get nodes. I have a master, and I'm calling it a master, but it's a manager and two worker nodes. So this it's running the latest version 1.22, and I use the kubeadm to create the manager first, and I added the other two workers. So if we see cluster info, it gives the information about where the control plane is and what it's using. And if I show you, I have Docker installed on them. It's running, and I have similar. I have on other worker nodes. So this is the worker nodes, and it also has the Docker running on it. So if we do a Docker version, I lost the connection. Okay, so if you do a Docker version, so if you see here, so this is my one of the worker nodes, and if I do a docker ps, see what all is running. And if I do a docker version, so the container runtime is required to run any orchestra, even Kubernetes or Swarm. So in this case, and it also has kubelet. So if you do system ctl status, so even kubelet is running on all the three nodes. So let's go back to the slides and see what are the various components. So as I was showing, this is the manager node. So what all runs on the manager nodes, and I will show you the each one of them going back to the terminal, is that this is the API server. API server is like the front end. It takes all the external communication, that commands we run, it everything comes to the API server. Then there is etcd etcd, which is basically the storage. It stores all the configurations and data. So if a manager node that's where all the information about what all is running inside the cluster comes from. So that's a key piece. And then we have scheduler, which schedules the pods, and we have control manager that controls the cluster based on the spec, which means your deployment specs, or like the YAML files, your manifest. So on both on all the nodes in a cluster, the three components that are common are kubelet, kubeproxy, and container runtime. Kubelet, these are all I installed myself, but if you have like a third party, and then you, like for example an EKS, this all will be already done by the service provider. And container, and the same thing is in the worker. So these components, they talk to each other, and then they make sure that how the pods are, where the pods are running, how the pods are running. And in addition to these components, there is a network piece, which is very important. The network, in my cluster I use Flannel, but there are other options. But the pod networking is a key piece, because when pods run on these um, nodes, they communicate with each other, and they share a network, which is an overlay network. So if I go back to my terminal, what I did is, on my etc docker daemon.json, I have specified the storage driver is overlay to, and C group driver is systemd. So that's in on all the nodes. So if I go and show you what all is running, so if I did get pods, right, I don't see anything, because in the default namespace, there's nothing is running. And I will go to namespace in the next session. But if I do minus all namespaces, then it's showing all the components that we just looked in the slide. So it has etcd, it has kube API server, kube controller, and kube flannel is with the networking piece. And then you have kube proxy. Now, if I do minus o wide, it will show me what all is running on which node. So most of the, as you see, kube master has all the pieces that we just saw. And in the worker one and worker two, it's the kube proxy and kube flannel. And Docker and kubelet we just saw. So kubelet systemctl, if I did, it is running, and Docker is running on all both the nodes. So we go back to the next slide, which is the last one for this, is the various components that we just saw. And then now in this case, this is how my cluster is in my lab. And this shows again the key pieces and how the communication is between the manager and the workers, the key components of it. And in this case, I've shown that there is an Nginx pod running on worker one, and there is a container inside it. So let's go and create that, because that's not running right now, and I will show you. And then there's a busybox pod. So if I go to my manager again, right, and if I, so there is nothing running, let me just check again. There is no pods running. But if I do a kubectl run nginx minus image, again I will just do nginx latest and let it run. So the pod got created, and if I do kubectl get pods, it will show me that nginx is running. We can also do minus -oy to see where is it running. It's running on worker one. Okay, it landed itself on the worker one. And if we do a kubectl describe, it shows further. It's basically used for debugging if the pod doesn't come up. Like if the pod is not running, then one way to go and debug is to look at the describe, and then you can also look at the logs. And it will show, so if there's, and then what about the container? So this is running on, we saw it's running on worker one, so let's go to worker one, and here we will see docker ps. So now if I do docker ps, I should see nginx also as part of it. This is the first one you see, that's the container. So this is the container that's running inside a pod, and the container is 1062. So if I do docker inspect on that container, then it will show me the information about the container. Yeah. So if you see, it will give you the IP it's running on and nginx and other information. Similarly, I can start a busybox pod, and it might go to any busybox minus image is equal to, I'll just get the busybox image, and let's see where it went. There are ways. It went to worker 2. Okay, great. So it's in a 0 to 1, which means it's not yet started. So there might be, yeah, there's a crash loop. So let's look at it. There might be, I might have to give some commands or something, because it's, so if I do describe busybox, so it pulled the image, but then it wasn't able to create a back off restart. So it requires probably some arguments. I can do a YAML with the, just a command to sleep, but I will do that in the next session. But I want to just show that how the two get created and deployed. And if I see if any containers are running on the worker 2, let's do that. Let me see if the busybox, you might not be able to see, it tries to come up busybox, you might not see it. Busybox is trying to come up. Yeah, if I do ps minus a, it will show me everything that is exiting at this point. So yeah, that's the first one. So it's not coming up. So definitely it needs some kind of input to continue. So I will do that in the later section, but that's it for now. So what we covered is the nodes, the manager, the workers, um, the nodes running in a cluster, various pods, and a very high level overview of what a cluster looks like.